Welcome to TERC Tech Talks with hosts Zach, Elise, and Ken. Today's topic is Snorkl.app.
All right, great. Hi, everyone. Thank you for joining us again for TERC Tech Talks. My name is Zach Alstad. I am a researcher here at TERC. And what we like to do here is explore the latest and greatest new technologies that emerge in the field of education. Oftentimes, we're talking about math and STEM, but we're really open to anything here. And with me are three of my excellent colleagues that I'm so grateful to share this little journey with. You want to hop in there, Ken?
Hi, I'm Ken Rafanan, also a TERC researcher.
Hi, I'm Elise Levin-Güracar, also at TERC.
And for our special guest today, we've brought with us Teresa Lara-Meloy. Maybe you could give a little longer introduction of what you do, Teresa.
I'm a ed researcher as well, but I focus a lot on designing professional development and activities for middle school students in mathematics. And I really care about math argumentation, which is the activity that I brought today.
All right, should we just jump right in? We were gonna use Snorkl today.
All right, sounds great. First, maybe give a little intro as to what Snorkl is and maybe what Snorkl tries to do.
Yeah, maybe you could do that.
You know it better than I. I would probably explain some kind of breathing device that's used underwater, but there's another kind of snorkel, and we're going to try it out today. What is that thing?
So think of Snorkl. It is an AI-based platform, but it is designed specifically for educational purposes. So, it has. Well, we'll see it, but it has like a whiteboard, and teachers can like set up problems in it, and then give those questions to their students. So it has, I think there's like a playlist part of it, but we're not going to get into that part so much.
Sure.
Maybe not today, but we're going to try it out with some problems that Teresa's brought along, and we'll just see how it goes, because we didn't do this in advance, and it could turn out terribly and this not be a very good tool for this, or it could turn out fine. Anyway, we'll find out. So I'm going to share my screen. This is just one that I signed up for free, and I just said I was going in as a teacher. Here, let me just sign out real fast. So I just used my Google login, and maybe I signed up. Oh, I must have signed up and said I was a teacher. And hopefully the AI at this point doesn't mind that we're being a little bit loose with definitions of teacher. So here we go. There's lots of different things. There's like, you could try a sample activity where they have a whole list of them. They have this other list that's called find an activity. How those two are different, I don't know. But today we're going to try to create an activity, right? So let's just try it.
And I just want to mention something. There also is another AI called Snorkl AI with an E between the K and L. So if you're looking for this one, it's Snorkl, SNORKL.app.
Thank you, Elise. Yeah, that's important. Don't go to where you don't want to go on the internet. All right, so Teresa, can you tell me the rough topic? And I'm just going to put that into the title.
I think we want to make conjectures about triangles.
I'm going to type in conjectures about triangles. So one interesting thing about Snorkl is that you can speak in your response, or you could just do sort of no audio. Obviously, like in a classroom, having 30 kids all talking out the responses might not work that great. But for today, for the podcast, is it all right if we let it use the audio?
Yeah. All
right, so I'm going to click on that one. And I haven't used this. Wait, at least we were playing with Snorkl the other day, and we set up some things. But it's saying add your question here. Students will respond on top of a copy of this whiteboard. So I'm going to just click add question. And Trace had given us, I'm going to switch over to Word, this question. Anyway, this is from our project that's called Visualize Teaching, which is all about supporting teachers in supporting the learning of mathematical argumentation in their middle school classrooms. But here's one of the questions that was part of the lesson. So it's write 3 conjectures and justify them using what you know about triangles. and we have these kind of sentence structures here. So I'm just going to copy this, and hopefully it will let me just paste it in.
Do you need that? Do you need the key that was above that, Ken?
Let's see. Maybe we were supposed to, but well, let's just see how it goes.
I might argue that yes, we were supposed to.
Okay. Well, let's just see how it goes, please. All right. So if I don't know what's going to happen. Like maybe the AI knows like, oh, we're expecting conjectures about triangles, but maybe it doesn't because it's using this symbol for a triangle instead of writing out the word triangle. Does that sound fine? Or you can tell me what to do. We'll do the driver navigator thing. You can navigate.
Well, can you tell me what happened? Like there's like this got printed into like separate little boxes.
So I pasted, I think this is saying like, oh, this is what you pasted. This is what it thinks that pasted thing says.
Well, that pasted thing has a square instead of a triangle.
Oh, interesting.
I believe that's a missing character.
Right. So like the all blank square should have been all blank triangle.
But so yeah.
I think that's a missing character if I'm not mistaken.
Like I pasted that part in because that one is number 5, right? But then it like couldn't interpret that thing, but maybe it could see it somehow because when it retyped it out as number 1 over there, I don't know what's happening.
I mean, that one on the left looks like an image.
Yep.
So you can replace that with the character if it is supported. Here in chat is a triangle.
But I think this one is that's just an image.
So
but maybe we don't need to. Can we try it and then we'll try to fix it if we have to. I'm gonna say done editing. Let's just see what happens. Oh, what? All right. Let's just try. Try as a student.
I think you might need a little bit more information on there. Like I think you might need the part that was above it, right? Wasn't
the
there
table on the lengths and angles of categorizing triangles by lengths and angles?
These guys, right?
All right, we'll put it in. Let's just see what happens. But so it created this part up here.
I guess I'm unsure as to why there are typable areas and image areas.
So in object character recognition, there is basically the AI attempts to transcribe the written information in a picture. And sometimes it does that accurately and sometimes it does not. And you can see those were the errors that you were finding when it does not accurately transcribe from an image.
So what happens if you delete the prompts that are typable? Does it? So that nothing happens, right?
Well, it may not have that written information anymore. I think it was doing its best to transcribe it, and it needs to put that written information into the LLM, I believe.
Okay, so perhaps undo and undo.
Yeah.
Okay.
We'll see. But the last time when I said try it, AI feedback settings. So it says tell our AI how to give feedback on student responses. And you could set it up manually. So after, well, we'll see what it does, but after the student answers, it will give feedback on that answer. And I think, Elise, right, we used just generate from the question last time.
Yeah, let's try that.
What's happening when this is churning?
That's what I was going to ask. Zach,
can you say that one more time?
Do you know what was happening maybe in the background as the thing was spinning?
So it's likely structuring it in a meaningful way looks like it was reformatting it into this. Well, meaningful may be debatable, but let's see here. So this is wholesale copying and pasting questions from other material into this, which you hopefully is going to work. And so you really want that object character recognition element to work really, really well for this kind of stuff. It looks like, for example, here, it looks like it got that triangle correct. So whatever kind of issue it was having before. So
I mean, the answer criteria table there looks correct.
okay, that's great.
Right equilateral triangles are not possible, and obtuse equilateral triangles are not possible. Everything else is possible.
And it would have been nice if it had made a proper table there, right?
Yeah. But it came up with those answers on its
own.
That's great. So and we're always kind of thinking about how a teacher might be using this. Like, how is this going to make life easier for a teacher? So if it's doing, all of that processing by itself, that's great. And then it's got some conjectures here. What do we think about these conjectures at the bottom? And if someone wants to read them out loud, that's always helpful.
So all equilateral triangles are also acute triangles. That's using the convention we gave it. And the justification it gives is, in an equilateral triangle, every angle measures 60 degrees, which is true, which is less than 90 degrees, also true. So it is acute.
Okay.
I don't know what the it is, but yes, there you go. Elise, do you want to read the next one?
Sure. The second conjecture says some isosceles triangles are also right triangles, but not all of them are. For the justification, it says an isosceles triangle can have a 90-degree angle, for example, a 45-45-90 triangle, but most isosceles triangles have all angles different from 90 degrees.
I mean, that's might be what a student does. And I would say that having just one example is not sufficient. But also, like, I don't know how it's making a claim that most isosceles have all angles different than 90 degrees.
Yeah, like why is it anyway?
That is not relevant to the justification, and also is another conjecture. So I would not even score this very highly in the justification space.
Right. It would be nice if the justification included the definition for what an isosceles triangle is.
Yeah.
And then the last one, the third one, it says no equilateral triangles are also right triangles. The justification says equilateral triangles have all angles equal to 60 degrees, so none can have a 90-degree right angle.
Yeah, that's pretty okay. Very concise.
Now I wonder, well, let's see what happens.
And you can
three conjectures, right? Like that's the important part about this an open argumentation space, is that there are sort of an unlimited number of conjectures that a student might make, and that's part of the design of the activity, and hopefully it knows that.
And so you can press the edit button here. Just try pressing the edit button. So if a teacher wants to modify something here, they can go into the prompt and answer material and add more things, delete them, whatever kinds of, so all those points that you were making before, the nuance of it could then be added, and definitely should be added by a teacher that knows what's going on here, rather than just kind of accept it wholesale, for sure.
Yeah. So I changed the most isosceles to isosceles triangles can have all angles different from 90 degrees. But I'm hoping that when the student answers, that it's not looking for these three conjectures.
I mean, is that true?
What? Is that they can have all angles different from 90 degrees?
Can they?
Yeah. Can't they?
No, they cannot have all angles different than 90 degrees.
I mean, if you have
an isosceles triangle,
right, we could have a 40.
The two lines of equal length are going to form
Yeah.
These two angles are going to have to be the same.
Yeah, but
it's another way of saying that none of the angles could be 90, right? It's possible that none of the angles are 90.
Or none. Is that what you're saying, Elise?
Yeah.
I'm just going to confirm it. Let's just see what happens.
Okay, yeah, right. And then
let's see what it does. Can we
and,
try?
okay, wait. Can you try? There's more options below. I just want to at the very bottom, very bottom, down. More options. I just want to see what other options they give in terms of student's default language. So that's cool. So if a student has a different language, it can output in that. That's very cool. Show correct or incorrect to both yes. So this is important. Okay. So yes, there's a correct or an incorrect answer that can be toggled, and then you can show their score.
Right. So a teacher could just keep the score to themselves if they wanted to, for who knows why, but
that's great. Very interesting.
I mean, I guess if a teacher put in a question that they knew that the AI was not very good about giving good feedback for, but you still wanted the kid to put it into the system because you're doing lots of problems on the system, then you're just like, yeah, don't give any feedback to the student. Just keep it to yourself.
Sure.
All right.
Yeah, so student view, or try as a student, I guess. See what it looks like. See how well it does.
Response. So it says like conjectures about triangles, whiteboard recording, start response. So we'll see.
So so you have to go. All right, so there's actually two math problems in here, right? We have the two on top of each other, and they're kind of, so it's a little bit convoluted. Okay, so then you can choose the tools at the top, including, a pen or text or formula or whatever, or shapes. Looks like we got shapes too. That's interesting, to respond. So I guess we could go back and modify the question to make sure it's just one question. Or what do you want to do at this point?
I just want to try it. Can we try it?
Sure.
I mean, I'd like to write a conjecture that is not one of the conjectures that were given.
Yes, let's definitely do that.
Do you want to type it, or do you want to mouse paint it?
Well, I'm going to start recording with the screen, and then if somebody, Teresa or Elise, if you wanted to give the answer verbally, and then I will try to match that with whatever I'm writing onto the whiteboard. And then when it comes time to write the thing, I can just switch into the type mode just to be a little faster. How's that sound? Oh, let's just try filling in the blanks. And then I don't know if it knows where the blanks are, but we'll see.
Okay. Give it a shot.
All right, I'm going to start recording. Okay, it says microphone in use.
Okay. Well, I'm thinking that there's only one kind of right triangle, and that's an isosceles. So I'm going to say that it's impossible.
Impossible for acute?
No, like right isosceles is possible, but I think right scaling not possible, right equilateral not possible.
Oh, I see. And we'll see if those x's, it was using like the x versus the check. See if my x's are in the right spot.
And I think only acute triangles are equilateral.
Only acute.
So those are possible. The other ones, I'm just going to be a student and say that they are impossible.
So impossible for acute scaling and impossible. Anyway.
Okay. Yes.
Okay.
What about obtuse?
We're just going to make them all possible.
See what it does.
Yeah.
I mean, people always tell me not to be obtuse in every situation. So that's pretty good. All right. So now conjectures.
Okay. You want to do the whole thing, or do you want to try and get feedback on just this part?
Oh. I would like to write a conjecture that is untrue.
Okay.
So given what we filled out in our table, I mean, we could say that
You're such a good student. You're like, I want to be consistent between my table and this sentence.
I want it to be like obtuse triangles can also be equilateral.
You want to not use the sentence frames, but a entirely.
Oh, that's right. Maybe that. How about some obtuse triangles? Oh, nice writing. Better than mine. Are also equilateral.
Oh,
Equilateral.
Sorry. Are we hoping that it recognizes your amazing handwriting?
Yeah, exactly. All right. I'm going to say end, and we'll see what happens. Let's submit. So up comes the screen. Oh, but it took away all of our answers. Oh, because it's converted this into a video.
Video.
So then it's going to, so we can play.
Right. So you use your voice to describe your own process, which is also quite cool.
Yeah. But if we drag this thing along, it can sort of see.
Look at that. Yeah.
Progress. Then we'll see.
All right. Let's see.
Let's submit. We'll see how long it takes to figure it out.
It's a long video.
Although I'm guessing it's not doing frame by frame. It's probably, compressed it already. We'll see. So now on screen we have a little, a very cute star. I think it's pretty cute. So it says that it's generating feedback. And we'll see how long it takes to generate.
Yeah, this might be a longer one.
So Zach, I just want to go back to something you were saying earlier, which is that you thought that maybe each page has to be a different problem or a different question. And we have potentially a lot of content in this page.
Right.
A lot of questions.
And it's analyzing a lot right now, I'm sure, with all of that. Yeah. Anyway, here we go. Okay, all right.
Answer incorrect. Okay, so under the feedback, it says answer incorrect, explanation 2 of 4, fair. And then it has these things like by the timestamp. And it says, I can see you're thinking about different types of triangles with a
emoji. Yeah.
However, can you think of a right triangle that might have 3 different side lengths, like a 3, 4, 5 triangle?
What do you think? Is that a good sort of response? We don't get a lot in terms of the students processing, right? So it's hard to see if there are misconceptions. Although if the student was talking through, and had some kind of misconception that they had externalized, then potentially it would get that in the audio.
So this is a little crazy. So it was listening to our conversation.
Right.
And one of us said, so I'm going to say that it's impossible. And then one of us said, okay, well, I'm thinking that there's only one kind of right triangle, and that's an isosceles. And so it picked up on that. I was like, I don't know what it's referring to. And then when you go to the timestamp, then you can sort of see what it's talking about. Huh. All right. Let's see what else it says.
I mean, just in terms of argumentation, that first suggestion is not something that we would encourage our teachers to do, but it's something that if you're getting feedback on a homework assignment might be helpful, which is to give a counterexample. And so the computer gave a counterexample for the student to think
with. Whereas if I were the teacher, I'd be ignoring everything. I would likely be ignoring everything until they're actually attempting the
justifications. Yes.
And it looks like we have three sort of response items here. I don't know if that's kind of hard coded to only give three, not to overwhelm the student. You know, you could have an enormous essay that the student's not going to read, right? But maybe
Yeah.
they kind of hard code a limit to what kinds of responses they'll give. Um,
Yes, although that second prompt or the response or feedback, like they're giving, like they're saying that's a great insight, which is, you know, sort of positively rewarding correct insights or true things that are already true.
Yeah.
Again, it's fine if it's homework. I would not do that as if I were a teacher because I want to encourage them to examine every statement they make, true or false. And that's what I would like to reward. But that, you know, this is a typical classroom. That might be fine.
Oh man. It doesn't even want to give us feedback on our conjectures. So you started working on the conjectures, but the assignment asks for 3 complete conjectures with justifications. Can you go back and fill in all 3 sentence frames using what you discovered about triangle relationships?
Ken, do you want to try and make a question that's real straightforward and just give it the conjecture and see how well it does? Maybe because it's up to you.
But can we try to finish this one?
Yeah,
Let's
of course, sure.
We'll see if what kinds of conjecture response it gives. So I'm going to
Do you have to respond in the same method that you originally responded in? Like, do you have to make another video?
But I'm going to upload the previous whiteboard so that we can just finish it.
So you can like iteratively improve your answer, I guess, which is nice.
All right, Elise, do you want to give us an all triangles something, all something triangles?
Do we want it to be correct or not correct?
Here.
I mean, let's give it correct and see what it says.
Okay, let's say all equilateral triangles are acute.
Oh. In real life, my handwriting is so much better than this.
Sure.
This is realistic for how a middle school student right.
Type on your screen. This is as realistic as it gets.
I'm going to put a big space at, like, I'm going to call them acute triangle.
Acute. Okay.
So,
how about, yeah, go ahead.
Ken, you did not press the record screen and voice button.
Oh.
That's okay, but maybe I mean, this is going to happen, right? So let's see what, maybe you go back in and just say some kind of conjecture and see how well it does.
Well, can you finish?
There.
Okay, let's,
maybe it'll just maybe leave it. All right. So let's just say no right triangles. Okay, I'm concentrating so hard on writing. Wait, Elise, did you make a true conjecture or a false? I didn't even pay attention.
Mine was true.
It's true. No right triangles are also what? Acute.
Isosceles.
Okay, that's true. Isosceles.
And misspelling is good.
The sauce. Oh gosh. Well, there's no way.
That's all right. I was using ChatGPT with a student earlier last week, and this individual has pretty intense sort of issues with dyslexia, and you couldn't really read what they had written on a full page. I put it in the object character recognition, and it gave us a full, perfect transcript of what they were trying to write with spelling correction. It was incredible.
Huh. I wonder what it's like. They must have a huge database. And it's like, well, everybody who does something like that really means this.
Optical character recognition, not object character. Optical character recognition.
All right. So I just said submit, and we'll see what it gives us.
Well, now it has to give us feedback on audio and not audio, right?
Yeah.
It's doing two formats of feedback.
When I tried it before, I gave only audio and it did kind of okay, like understanding it.
Mm-hmm.
That's really great for, our neurodiverse students. So I don't know how much it's going to draw on the previous answers here. You might have wanted to try and correct one of your other answers just to see what happens.
Well, it's giving you feedback on writing out the 3 conjectures. And it is evaluating them.
This is so interesting.
Can you read it out loud?
So it's saying your conjectures need justifications to explain why each statement is true or false. What geometric properties support your thinking, which is great, but our question did not ask for that.
No, it says justify. Write 3 conjectures and justify them.
Oh gosh. Why do
Now, the thing is, like, it also has been providing us with the justifications all along.
Well, yeah, if somebody listened, I guess.
I mean, no, like in this page, your first conjecture about equilateral triangles being acute is correct. So I've already known that it's correct. I don't even have to justify it because I already know it's true. And shows good understanding.
Yep.
And then the second one is sort of interesting. It's very kind. I noticed some confusion in your chart entries. Can you think about whether it's possible to have a scaling triangle that is also acute? I mean, I literally thought about it, and this is my answer.
Right.
But I mean, it is really impressive that it can understand our talk, even though we sometimes talk over each other, and that it is seemingly understanding the mathematics.
Can you press the speaker button on the right of one of those? No, on the responses there. Just yeah. What happens when you press that?
Your conjectures need justifications to explain why each statement is true or false. What geometric properties support your thinking?
That's great. So we got lots of modalities for both input and output. Again, our neurodiverse students, I think that's really a big asset for them. Really like that part of it.
Wait, can we play I want to play the second one to see if it, oh no, I guess it kind of ignores emojis.
Oh. So.
Well, I did want to see what what it would say about our, but it's like running out the clock on us by not giving us any feedback along the way. I just want to know what you're gonna say. Wait, can we? All right, really quickly, let's try. I'm gonna respond again with the previous whiteboard. I'm gonna just make a justification.
Can you type it in? Just type it in, please.
Let's just say it. So one justification is all equilateral triangles are also acute because equilateral triangles have 3 60-degree angles, and that would make them all acute angles. Some obtuse triangles are also equilateral, but not all of them are, because some obtuse triangles are 60, 60, 60 triangles, which are equilateral, but not all of them are. And no right triangles are also isosceles because you can't do a 90-degree angle with any other 2 angles to get 180 degrees.
Well, good job at being a student.
Well, I guess whatever. I was trying to make it make some sense, but maybe it doesn't really care. Obviously, it wasn't correct, except for the first one, but.
I mean, it is pushing you to finish your assignment, which is also pretty impressive. That is, even though it is giving you hints in the middle, it's also not letting you off the hook until you complete your assignment.
I have to say, writing with a mouse, I start feeling like a student. Like I've done this homework assignment. I want to be finished.
Let me just say you actively refuse to use the typewriter.
That's true. I could have
You're going to power through that.
It's still giving me a 2 of 4, and we put in so much work.
Well, can you read that first one?
All right. Great job providing a clear justification for your first conjecture. That's really Elise's conjecture, but we won't tell it. About equilateral triangles being acute. Your reasoning about 60-degree angles is spot on. So this is so interesting because we only have this video over here and we don't have it written out what the justification was. I think if I'm a kid, I'm like, all right, I'm just accepting what you said. I have no idea what it's referring to necessarily.
That they should have made that explicit about exactly what you got right. Yeah. Or rather what Elise got right, not you, Ken.
Oh, shh, don't tell it. So this is this gentle thing, like, I'm curious about your second conjecture. Can you think more carefully about what angles an equilateral triangle actually has, and whether any of those angles could be obtuse, which is greater than 90 degrees. And then for the third one, for your third conjecture, what do you know about a 45-45-90 triangle? Could this type of triangle help you reconsider whether right triangles can be isosceles?
That's nice. It's, again, it's doing the justification for you by giving you a counterexample.
So Elise, earlier you'd said, like, and maybe you've done this with some of your students recently, of like, it would be good to talk about the definitions of what each of those types were, right? So this, it's not saying like, think through again, or tell me again what the definition of an isosceles is.
Right. It's not really trying to get at like why you might be getting the problem wrong.
Yeah. Whew.
It also seems like it's kind of hard limited in terms of the length of each individual responses. It looks like it hasn't given one longer than 1 or 2 sentences, right? And it might require a little bit more detail to get to that pointed sort of response, that pointed feedback.
Yeah, that's interesting.
And I wonder if it won't sort of give you a higher grade until you correct, like literally cross out and correct things. You know what I mean?
Yeah.
So thanks to our guest for bringing us a really interesting problem to try out and trying to do some argumentation with AI, which we haven't really gotten to do before. Thanks for being here.
Thank you for inviting me.
It's time for TERC Tech Talks top takeaways.
We said grades. What's the other score that we're going to give them?
I'd call this kind of clanky for argumentation.
Yeah. What do you think, Elise?
Yeah, it's a very open-ended problem with a lot of correct answers. And when it initially gave us answer options, it only gave us 3. So it didn't give us a lot to think about as a teacher with what students might put in there. And then it didn't have a lot of guidance when we put in incorrect answers that would kind of step by step get us to something that actually worked.
Excellent. What do you think, Teresa?
I was impressed that it was engaging with the arguments in a correct way, because I've tried it in other chats and often they just give you crazy answers or just wildly contradictory ones from one time to another. So this was really impressive that way. But I agree with Elise that if I'm the teacher, I need a lot more work, because otherwise I have to type in all the possible answers myself, which is the thing that would be less, like, that's the one place where I want the help.
Yeah.
So all potential answers that could come out of it, that'd be nice if that was generated, allowing for many different sorts of paths to a correct answer for sure.
I'm kind of focused on the interface. I really like that ability to switch between the different means of input. You can type, you can draw, you can chat or do any kind of combination of those. I think that's really, really nice for when students would like to
articulate in whatever format that's best for them. And I would have appreciated that sort of thing, because we think about neurodiverse individuals and how sort of if they have to participate in one modality, that serves as a filter for some of them. So yeah, but overall, I like where they're going with it. If it's still a little bit rough around the edges, so to speak, of the triangle. Sorry, this stupid joke.
Teresa, thanks so much. I know you got a jet.